Hi, this is going to be the first part of a few videos on using something that we call exponent properties. So this is part one of that. The exponent properties are rules that they're just rules that allow us to quickly figure out a multiplication problem between two numbers, a division problem between two numbers, and a few other little tiny tricks. What's really great about them is it really speeds up the fact that sometimes you don't need to multiply two numbers together because they'll cancel, or they'll combine into a bigger number that you don't have to worry about. So it makes life a lot easier and it speeds up certain parts of multiplying and dividing. Today the videos, all the answers are going to be left in exponential form. So we're just simplifying all the answers into exponential form. If you've seen in my notes, I'm going to be doing this 3 different ways. The first 2 ways are going to be pretty straightforward, and the third way is actually going to be using the rule, which if you notice I have barely any space for, because the rule is pretty fast once we think about it. So I'm going to do this. I'm going to actually be combining numbers so that, like with the colored pencils that I have with me, just because using the colored pencils is, well, it just makes life a lot easier. So I have 3 to the third power times 3 squared. If you notice, the base is the same. The base is 3. So I'm actually going to do this a little intuitively in this thinking. I have 1, 2, 3. I have 3 3s. Normally we'd multiply 3 3s, right? And I have 1, 2 more 3s. So my question is this. Well, what do I end up with? If you notice, now I have 5 3s. Well, if I have 5 3s that are all multiplying together, I can just rewrite this as 3 to the 5th power. And that's it. So the first method, pretty easy, right? We just draw some shapes. The circles stand for a 3. Makes life pretty easy. Let's go on to the middle one. The middle one is actually me expanding them out completely in expanded notation. So the first thing I'm going to do is this. I'm actually going to rewrite this. I just dropped that colored pencil. 1 second. Didn't break. Okay. Apologize for that. I'm going to rewrite this. I'm going to use the same color for the base. This is 3 and that's 3. I'm going to use the same color. I'm going to use one color for this exponent and a different color for the other exponent because they're different. Okay? With me so far? And they're multiplying together. That operation is very important. So if that's the case, I'm going to rewrite this as, well, I have 3 3s that are multiplying. So I'm going to expand 3 to the third power out. 1, 2, 3. So this is 3 times 3 times 3. That's from this 3 right here. 1, 2, 3. Right? And I'm going to expand this other one out. I have 3 times 3, and I have 2 of them. Right? Well, if you notice, the base is still the same. Now I'm just going to ignore everything before, and I'm going to say, how many 3s do I have right here? Well, I have a base of 3. That's still the same. And I have 1, 2, 3, 4, 5. So my answer is 3 to the 5th power. Notice the base didn't change. The base is still 3. The exponent changed. Right? Same thing over here. Base stayed the same. The exponent changed. Well, let's look at the exponents because that seems like that's where the action's happening. I have 3 and 2. What operation did I have 3 and 2 with that gives me 5? What operation do I have 3 and 2 with that gives me 5? 3 minus 2 is 1. That doesn't work. 3 times 2, that's 6. Hey, 3 plus 2 is 5, and that's our rule. I'm going to skip down here to the bottom real quick. When you're multiplying powers with the same base, the base has to be the same. I can just add the exponents together. So this is to a power, this is to an exponent. M plus n, took the 2 exponents, add them together, that's my answer. And that's it. Hey, that's pretty easy. Let's check that over here. I'm going to rewrite, and notice I'm rewriting. I have it written in black first, and then I'm writing it in color. Times symbol. This is to the 3rd power. This is squared. And if you notice, hey, my rule says the base stays the same, so that's still 3. And then I'm going to add them together. I don't want to see 5 all of a sudden. I want to see 3 plus 2. I want to see that first. Is equal to 3 to the 5th power. Done. That's it for this rule. So 3 different ways of doing it. These two are pretty straightforward. This one, yeah, it's a little more writing. But eventually you want to use this method using the properties. But if it takes a little more time, it's okay to use this property for a little while. But eventually, got to use this one. Okay? So that's multiplying powers with the same base. What happens if, oh, I don't know, what happens if we divide? Well, multiplying, the opposite of multiplying is dividing. I can't remember what the opposite of adding is. I just don't remember. So I guess got to try it again. No, okay. There we go. Let's look at this second example. 4 to the 6th power divided by 4 squared. Let's check it out. I'm going to take my 4s, and I have 6 of them up top, right? 4 6s up top. 1, 2, 3, 4, 5, 6. And this is being divided by 4 squared, so I have 1, 2 4s down there. So basically, instead of the 4s, I'm putting circles. I'm putting triples. Those green triples. Well, if the number is the same on top and bottom, that just equals 1. This equals 1. This equals 1. So I'm going to rewrite. I have 1, 2, 3, 4. I have 4 triples left over. So that must be 4 to the 4th power. That's basically it. Let's do it with just the numbers. Now I'm going to use expanded notation. I'm going to rewrite this. 4. One of these is to the 6th power. The other one in a different color is to the 2nd power. And by the way, colored pencils are a big deal in this section. Really use them, guys. So I'm going to divide. Well, let's expand it out. We have 1, 2, 3, 4, 5, 6. All multiplying together. And then I have 1, 2. I have 2 4s multiplied together. We all know what 4 divided by 4 is. 1. 4 divided by 4, 1. So all that's left is, and I'm going to rewrite it to make it look good. Please, you've got to do this. And you might be thinking, Mr. V, I can count. Don't worry about it. I don't have to rewrite this. When more than one number starts showing up or the variables get involved, this gets really complicated. So you've got to do this because it can get a lot harder, and it will. So use the color pencils. Go step by step. Take your time. Okay. So this is 4 because that's the base. 4 is everywhere to the 4th power. So I'm sure by now you've looked at the exponents and you said, well, 6 times 2 is 12, so it's not that. And it's not 6 divided by 2 is 3. So it must be 6 minus 2. And you, sir, you would be correct. If we're dividing powers with the same base, we can use this law. The base stays the same. Again, the base isn't changing. It's 4. It's not changing. But I am subtracting the exponents. And that's basically what we're doing. So let's check this last one up. Let's use the rule. I am going to color code yet again. This is 4. This is 4. This is a 6. This is a 2. I'm going to put another equal. And then we've got 4 raised to the, what are we doing with the exponents? We're going to subtract 6 minus 2. So we have 4, because that's the base, to the 4th power. That's the exponent. So if we're multiplying, what do we do with the exponents? We add. If we're dividing, what do we do with the exponents? We subtract. We're doing a lot of this the next few days. And the problems get better. Man, a lot of fun by the end of this section, I think. The last property. And no joke, I think this one's probably the hardest. 7 squared in parentheses raised to the 3rd power. So now you have to take 2 powers. Dude, what? No way. Oh yeah. Don't worry, I got you back. Here's what we're going to do. Ignore that first. This is 7 squared. So I'm going to take 2 triples. I'm going to draw 2 triples for 7 squared. Because of the 2. Now there's that 3. So whatever's inside of here, the parentheses, we're going to write again 3 times. We're going to have 3 groups of whatever's inside the parentheses. 3 groups of. Where have you heard that before? 3 groups of something inside of parentheses. Ah, don't worry about it. Who knows? Maybe it was in another lecture that you might want to go watch. So I'm going to copy this 3 times. My question now is this. How many triples do you have? 1, 2, 3, 4, 5, 6. We have 7, and 7 has shown up 6 times. How do I get use 2 and 3 and get the 6? It's not adding or subtracting. Very mysterious. Why don't we try this? Let's use a little more common sense. That's kind of hard to see with the triples. I think the middle method's actually the best way to see what happened. So let's see that again in instant replay. I'm going to draw 7. I'm going to use 7 in green. I'm going to use red for 2. I'm going to write 3 in blue. 7 squared to the 3rd power. Let's think about what this is. We have some number to the 3rd power. If I had some number to the 3rd power, how many times do you write it? To the 3rd power, I write it 3 times, Mr. V. That's right. So I'm going to put 3 parentheses, 1, 2, 3. And what goes inside of every single one? The exact same thing. 7 squared. Oh, great, Mr. V. Now I got 7 squared. Well, how many 7s are there? Let's expand it out even further. In each parenthesis, we have 1, 2. 1, 2. 1, 2. We have all these 7s multiplied together. 7, how many 7s do you see? 1, 2, 3, 4, 5, 6. Hey, 7 to the 6th power. What operation have you used on 2 and 3? 2 times 3 is 6. And that's the last property. If I have a power that's a base, this is A is the base, and it's already 2 power, and I raise it to another power, I multiply the two powers together. And that's the new power. That's the new exponent. Crazy stuff, right? I'm going to rewrite, of course. 7 squared raised to the third power is equal to 7 to the 2 times 3. I'm multiplying my exponents together, and we should know 7, well, 2 times 3 is 6. Three new properties, 3 new things that you have to remember. But if you remember everything that you've learned already, you don't need to know the rules. You can figure it out on your own. It'll take a little bit of work and it's a lot of steps, and you can figure it out. But the rules, they speed it up so much faster. And that's the main idea that we really want to focus on for this part of the unit. The properties make life so much easier. Just like the algebraic properties makes life so much easier, these are the exponent properties, and they make life so much easier. So that's part 1. Get ready for part 2. It's going to be fun.